Okay, so I promised to go over this bonding practice before the ODM. So here we go. With this unit, the number one thing to get bonding is, first off, we got to be able to identify whether any one compound is going to be ionic or covalent. To do that, we got to take a look. Got to take a look at what we're given. Every ionic compound, ionic means we're going to have a metal and then a nonmetal bonded together. If it's covalent, it's nonmetal, nonmetal. So, or it's two nonmetals of the same type bonded together. So, really, all I have to, they're both going to end in nonmetals. I have to take a look at this first one. Is that a metal or a nonmetal? Well, how the hell am I supposed to know? I'm supposed to know because I look at my periodic table. I find my zigzag line. Anything that is on this side of that line, including this stuff down here. Now, come on. We're never going to come up with dysprosium. But in the off chance that, someday you have to go, oh, hey, is dysprosium a metal? Yeah, it's a metal. We've only got nonmetals right here with one exception, and that exception is hydrogen. Those are our nonmetals, people. So, and then, you know what? Forget about these guys, because these are noble gases, and noble gases never bond with anything. They don't form bonds because they got that full valence shell that we keep talking about. So, once we do that, once we know if it's ionic or covalent, we can do the other stuff. So, to do the Lewis structure, for one that is, actually, you know what, let me go back here. So, to do the Lewis structure for MgO, here's what's going to happen. I'm going to have Mg. The valence electrons are 2. I know why the valence electrons are 2. Valence electrons are 2 because it's right here in the second row. Oxygen is going to have 1, 2, 3, 4, 5, 6 valence electrons. We count over from the left to figure out how many valence electrons we have, skipping those groups in the middle. So I drew that kind of close. I don't know why I'm saying it like that. Anyways, so oxygen's going to have 6. Now here's what's going to happen. Magnesium wants to get rid of 2 because now it's got a full valence shell because it's going to look like it's a neon. And these 2 electrons come over here, and now oxygen has its octet. It's 1, 2, 3, 4, 5, 6, 7, 8, and it's happy. This is how magnesium forms an ion with oxygen. So it's a +2 ion, oxygen's a -2 ion, and everyone's happy. So that's what it would look like here in the box. When I name this, naming ionic compounds, I never use a prefix. I just write the metal name, magnesium, and then I write the nonmetal name, I end it in "ide." So oxygen becomes oxide. Done. CO2. C is a nonmetal. So it's covalent. We already did the bond structure. Remember, these dashed lines count as 2 valence electrons. So each one of these should have a total of 8. So 1, 2, 2, 4, 5, 6, 7, 8. 2, 4, 6, 8 for C. 2, 4, 5, 6, 7, 8 for this oxygen. These ones we do use the prefixes. So this is carbon, because we don't start with mono. And this is going to be dioxide. If it was just one O, then it would be carbon monoxide. We never call something monocarbon. That's crazy talk. Hydrogen. Hydrogen is the weird exception where even though it's over here, it's still going to be covalent. If I do H2O2, when I draw that, so here's how we draw the bonds if we've got a covalent. First, we want to start with my H and a dot. I'm going to have oxygen with my 6 valence electrons. Every oxygen atom has 6 valence electrons. So hydrogen can only make one bond. Now it's got 2, it's got a full valence shell, it's done. The 2 oxygens are going to bond with each other. They're going to share one between the 2 of them. And then we're going to have another hydrogen bonded over on the side. That's how we're going to make H2O2, which is different than H2O. H2O would just be that, right? You get the idea. No O there. And that's dihydrogen dioxide. LiBr. So I look at Li. I go lithium. Lithium's number 3. It's right here. It's a metal. So it's a metal. It's ionic. Lithium has 1 valence electron that it really wants to get rid of. And then we've got Br. So lithium is going to give, and so Br wants 1 more. Lithium has 1 more. Lithium is going to give its to Br, and now everybody's happy. And we've got a +1, a -1, and now we're bonded. To name that one, that is just going to be lithium bromide. FeCl3. Fe's iron. Goodness gracious, you should not have to look at the periodic table to know that iron is a metal. Naming it first, Fe. Iron's a metal. Iron's one of these transition metals here in the middle. So we got to figure out what type of iron it is. It's going to have a parentheses. So iron, parentheses. So if you see how this is a 3 here, every Cl is a -1. That means this has to be a +3 to make the whole thing even. It's this +3 here that goes and gets spit down here as the Roman numeral. So that's iron 3 chloride. Oh, look at that. So, Fe is going to have 3. Now, it's FeCl3. That means I better have 3 Cl's when I do my Lewis dots. Oh. Boop, 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 boop. Okay. Now, these iron ones are just going to get transferred over to the chlorine. Iron's going to end up being a +3. Each chlorine's going to want to attach to it. It's going to make that big complicated molecule there. So iron's giving it all away to 3 different chlorines. Okay. SO3 is going to be covalent. S is for sulfur. So sulfur is right underneath oxygen, and this would be sulfur trioxide. So sulfur and oxygen each want to get 2 more bonds to each one. So what's going to happen is they're going to form bonds like this. The light's
Miss Robinette, if you're in the building, please call the front office. Miss Robinette, if you're in the building, please call the front office. Thank you.
Oh. Man, Miss Robinette ain't going to be around. It's 3:11. So, that's what it's going to look like when it's bonded covalently. I got to get up and turn the lights on. I mean, if you're still watching this 10 minutes later, there you get a little bit of like a little break in the action. Okay, K2O. K, it's potassium. Potassium's right here, so it's ionic. We've got two potassiums giving oxygens some valence electrons. And that's just going to be potassium oxide. NaF, Na is definitely sodium. Sodium is a metal, so that's that's ionic. That's going to be sodium. I don't know why I did that. Sodium. Fluorine becomes fluoride. Sodium fluoride. When we bond that one, it's basically going to look like LIBR because we're taking a look at two things that are very similar. So, because they're in the same groups. So, Na is going to give that electron over to fluorine right there. And that's my bonded Lewis dot diagram. N2O3. Oh man, N2O3. N2, well, N is non-metal, so this is going to be covalent. So this is going to be dinitrogen because I've got N2. Trioxide. So let's see, dinitrogen trioxide. So my nitrogen are going to want to bond with 3 partners. Then I'm going to have oxygen. Each oxygen is going to want to bond. Oh, you know what? So this is going to go together like this. So we've got a double bond here, a single bond, another single bond, and then, then I ran right out of the frame. And then way off in the distance here, I'm going to have one more double bond. So writing that more succinctly, it would look like O double bond N, single bond O, single bond N, double bond O. And then we would have our other valence electrons on there as well. So each one of these, when we add them up, we should have a total of 8 valence electrons for each one. So 2, 4, 5, 6, 7, 8. 2, 4, 6, 7, 8. And then the rest are going to be just the same thing. Okay? So that's dinitrogen trioxide. Now, last one, we've got potassium, so it's going to be ionic. This is going to be potassium iodide. So we've got K with one I, we've got I, looking for that last valence electron, and it's going to come from K. Okay? So there we go. K is going to be positive, I is going to be negative. So look over this stuff, be able to do it yourself. If you actually want to do well on the ODM, you can come and sit and take it, and maybe you'll snatch a point or two. Really rather have you, understand this stuff better than you did before. Kind of the point. Okay, well, have a good weekend.